today I'm going to talk about our system, the sounding board, which we developed for the enterprise, and also talk about some recent research we did based on the data we collected using this system. So here's a brief overview of my PhD study. So I did a lot of different things, but if you are interested in knowing any of these things, I can talk about after the talk. Today, this talk will focus on the Socialbot, which we developed, I was mostly involved last year and this year. So the talk will have 4 parts. So firstly, I will share our own perspective about the Socialbot as a conversational gateway. And then I will talk about our system, the more details about the system. And after that, I will introduce our recent work on modeling multi-level rewards for scoring long Socialbot conversation. And finally, I will conclude the talk with some summary and the future work. So by the way, the first 2 parts, Mari kind of mentioned in the Knuckles keynote. So but, if you have questions about those, you can ask now. And I will try to have several different perspectives in the talk. So yeah, so if you think about the conversational AI system, one thing we are looking at is how the user's scope specificity differs. So like in a virtual assistant, so users have a very specific goal. So they try to execute commands, or they try to have the system answer the question or set alarm. Whereas in a different chatbot, like the chatbot, like the Alexa or the CLIs in China, so they are more like to have in general conversation where the user does not have some specific goal, they just want to talk. Whereas in the Socialbot, which Amazon want to build, is a bot that can converse on popular topics and recent events. So the goal is not as specific as the virtual assistant, where you just want to finish a task. But on the other hand, it's there's some more specific goal than the chit-chat because they want to talk about the recent things and the popular topics. So that's the way we think about where the Socialbot stands in the space of conversational AI. And so the overall design philosophy of our bot is twofold. So it's like when you want to, when you go to a cocktail party or any party, you want to join the conversation. And so you must be pay attention to the other participants, try to acknowledge their emotions, reactions. On the other hand, you want to bring in something interesting and relevant information into the conversation. So that makes our two aspects of our design philosophy. So it's user-centric and content-driven. And here is a sample Socialbot conversation between the sounding board and user, so to give you some kind of initial idea about how it goes. So the user can come with some specific topic, like say, let's talk about the book, The Rise of the Superman. And the bot may not have something about the book, but then the bot will try to kind of steer the conversation to a relevant topic. So the bot proposed a relevant topic, like the movie, the Batman versus Superman. And the user can kind of accept this topic and start to engage in the conversation. And so the bot will say, OK, I like that movie. Try to pay attention to the user reaction and try to acknowledge that. But then it tries to push the conversation forward by kind of request the user to share some opinion or experience about the movie. And the user can start say something, and then the bot may or may not understand what's going on, so it just say interesting. But then the bot will say, OK, I will give you some more information about the bot. So it gives the rating. And then tries to push the conversation forward by saying, OK, I also know something about the actor. So do you want to hear? So if the user accepts that, the bot will just provide some it found online. So the whole conversation is kind of grounded on the online content or all kinds of information. So for example, the rating is grounded based on some IMDb information, whereas here, this little interesting trivia is which is grounded based on some Reddit discussions. So that means we can treat this whole Socialbot as a conversational gateway to all sorts of online content and try to route the online content intelligently to the user, based on the user's interest, based on the conversation context. And the online contents can be like these social media discussions, can be news website, or can be this IMDb or Wikipedia, those more structured data. And so the user come to talk with the device using their voice, and then which is backended by the sounding board. And the whole thing you can think about is a kind of a conversational user interface, whereas in traditional, we just go to the web interface or use your phone app to interact with this online content. So therefore, we can see like the way we view the sounding board is just say, okay, we have a new conversational user interface that is kind of act as a conversational gateway to the online content. So next, I will talk about more about how we build this system. So as we say, as we know, so as I said, the Socialbot is kind to try to ground the conversation on the online content. So the first thing we need to do is to do a lot of content mining, which we call the content management. So we first crawl a lot of online content every day. But the second step we do is to filter all those inappropriate or depressing content. Because first, the Socialbot has a wide variety of users. So they can be children, they can be like senior people, or they can come from different countries. So there's something we cannot say to the children. So but there's a lot of things online that may not be good for like family-friendly discussion. So we try to filter those content out. But at the same time, we also want to filter some depressing content, like there may be some news, there's some people doing bad about cats or dogs. But if a user comes to say, let's talk about cats, and we share something that is depressing about this like pet lovers, so then the user also tends to unhappy about the conversation. So therefore, we develop our own filters to filter all this kind of information. After that, we will index all this interesting and uplifting content. How do we do that? Here is an example. So let's say we have a news, which is about UT Austin and Google, and doing some machine learning things. And then we will run the parser over this content, and then try to find what the noun phrases, what's the entities, and also we use this meta information like science astronomy, which comes with the news in the source website. So all of these things can be used as an index topic of this news. And then we can build a knowledge graph based on this, all this kind of content, where we treat each content as a nodes in the knowledge graph. And the edge can be all these index topics. And currently, the system maintains 80,000 entries of this of all the content and 300,000 fine-grained topics. And also, the knowledge graph is daily updated, so we can talk about most recent things and most what happened recently and the popular topics. And here is some like visualization of the knowledge graph, where you can see, again, each node in this graph is like a piece of information. It can be a news, it can be a discussion post, and also it can be some like joke or even movie. So let's say the user come to say, let's talk about science, we may land it on this central node. And then you start to engage in the conversation. Okay, say if we say, do you read this news? You say no. And then the next thing we need to decide is, okay, what we say next. So we can choose from this UT Austin or AI or Google or NASA, any of these, and try to traverse the graph from one node to the other node, and then kind of to push the conversation forward. So that's the way we do this content-driven conversation. And so now here is the overview of the system architectures. So the content management happens here in the backend, where we daily update our backend database. And then in the front end, the Amazon has this their Echo device, where it will do this automatic speech recognition and do the text-to-speech synthesis. So the thing we got in our system is the transcribed speech with some hypotheses. And then the thing we need to send to the device is just the markup prosodic markup language of the response. So there's in the middle end, there's three key components: the language understanding and dialog management and language generation, which I will talk in the subsequent slides. Again, so back to the design philosophy, we have two folks: the user-centric part and the content-driven part. For the user-centric part, we try the long-range understanding will try to understand this fine-grained user intent and the reactions. And the dialog management will estimate the user personality and handles their user goal changes or topic changes, as well as to track the engagement of the user. And for the generation part, we use the template-based generation, but with appropriate prosody and grounding based on the understanding and the dialog management output. And for the content-driven part, so we have the dialog management tries to ground the conversation on the online content. So we are not just generate some hallucinated news or hallucinated jokes. And also, as we talk about, we have a knowledge graph that with daily update online content. So for the long-range understanding, we are using a multi-dimensional utterance representation. Like here are four major high-level things we try to detect, but they are all the fine-grained dimensions we are trying to do. So for the commands, there can be the tell me a joke, but can be also these navigation commands like next, cancel, or continue. And for questions, we are trying to understand whether this is a personal question or factual question, or some inappropriate question we should not answer and we should deflect. And for topics, we do a very greedy detection of all kinds of candidate topics. We try to identify what's the primary topic of from the user intent or the candidate topic in the utterance. So there we rely on this syntactic parsing and the name entity recognition. And finally, we are looking at the user reactions to the system response, try to understand what's the user sentiment to the system and what's their opinions, their confirmation state, acknowledgement, all these things. And in order to understand to build this multi-dimensional utterance representation, we are using a two-stage process. So the first process is to have a state-independent model for those complete or regular utterances. Like the user can come to say very full utterance, like let's talk about technology. Or sometimes the user can be very short, like they just say technology. And so therefore we need to second stage, which is a state-dependent process to handle these ellipses in their their utterances. And so here is there are two different types of users. There's terse users, which do this very short utterance, like cool, yes, no, and no, I didn't know that. So those things, these kind of doing these ellipses, we need to know the context of the conversation in order to understand what the yes and no means in the actual context. And that's actually relatively easier to do versus there's the talkative users, which try to express their things in a very very complicated way. So they may think the system can understand that, but actually it makes the system harder to understand because first, as they have longer utterances, the speech recognition system recognition error will increase. And then also there is the challenge that we don't get any sentence boundaries in the speech transcripts. So it's hard for us to segment where the sentence where is the sentence boundary. And so, but the way we do that is we have a lot of fallback strategies. Like say we try to see which part of the utterance we can understand, so we can choose one thing to acknowledge. That's the dialog management tries to do. So it tries to first acknowledge the user based on the understanding output. And then it will try to see, OK, I want to push the conversation forward, so can I introduce some new content into the conversation? So that's the master dialog management want to do. It ranks the topics and mini skills or content, where it considers this topic or coherence or user engagement and all the content availability. So one thing we introduce is the idea of the mini skill, where it can manage a local coherent conversation, kind of sub-dialogue in the conversation. And so the master dialog manager can delegate its control to the mini skill, where the mini skill can do kind of things like greeting, or discuss a news article or movie, or probe the user personality. So the good thing about using this hierarchical dialog management is that we can easily swap in new mini skills or upgrade one module that does not change the whole system a lot. And actually, in the competition, we add 7 or 8 things at the end of the competition, which give us a lot boost of the user ratings. So to give you some idea how this mini-skill goes, so the conversation starts by user by saying, like, let's chat, and then we'll do the greetings, like, how's your day? So that's the greeting mini-skill. And the user will say, I'm 5, but there is the as an error we detected. We kind of can look at what the other hypotheses are. So we can detect that I'm fine. And so we are doing some grounding, say, glad to hear it. And then start doing some negotiation, say, we can talk about all these topics. And user can give a topic. And then the first thing the system tries to do is to share a fact about this topic. And as the user is engaged, the system tries to run all the other mini-skills. Now we use the sort mini-skill. And similarly, we do the news and then have some advice and then talk about some movies. So this is each individual segment is kind of handled by a mini-skill where the whole conversation is managed by the master dialog management. So the last part is doing the language generation part. In the system, we mostly use the template-based generation to control what we are going to say to the user, rather than just rely on a model that can say anything to the user where we may not want to say. And so the most important thing important step we are doing is to divide the template into several different kinds of speech acts. So the first thing is the grounding act, which tries to ground tries to do this conversational grounding, make sure the user and the system are on the same page, because we are doing this voice-based interaction. So sometimes there's the speech recognition error, sometimes there's a language understanding error. So we try to let the user know that what our internal state are. So here we say, I'm glad you like it. It's kind of meaning that we detect the user is happy about the conversation. And then the next thing is tries to push the conversation forward. Therefore, we use this inform speech act, where we for different types of information, we will have different inform acts. Like for news, we can say, I read this article from yesterday. Or for facts, we can say, did you know that? Or for thoughts, we can say, have you heard of this idea? So all kinds of these different variation of ways to express to inform the content. And the third thing we are doing is the explicit request act, try to kind of engage the user in the conversation, try to get the user attention. So rather than just finish here, I read this article, we will ask some question like, have you read this news, or what do you think about this news? Try to encourage the user to share their experience or opinions about this thing. And finally, we have an instruction act, which when the user is don't respond or don't know how to move forward, so we can instruct them with some simple commands, to navigate the conversation based on the next or skip or continue, all kinds of these simple commands. So the system during the competition, Amazon have 2 different evaluation protocols. So one thing they're looking at is the conversation ratings given by the users after they have an interaction with the system, so which is optional. And in the finals, they actually invite 3 interactors to talk with the bot. And then there are 3 judges sitting in the background, listen to the conversation. And then when they think the conversation is no longer interesting, they will press the stop button and end the conversation. After that, they will give a rating from 1 to 5 to rate how the conversation goes. And also, they use the duration of the conversation as a tiebreaker, but we never use that. And so in the finals, the system are rated by these judges, and we get an average rating of 3.17. And the duration is very significantly better than the other teams. It's 10 minutes and 22 seconds. And we don't know the number of user turns, but we also did some analysis on the post-finals system, which is kind of the same stable system we have within 1 month. So this conversation are rated by the customers. And you can see customer tends to give a higher ratings because sometimes they want to engage in some jokes or some I think it's mostly they want to do some games, the jokes. So they might rate you differently from the judges, what they are looking for. And the duration is much shorter, actually, so they may just go away if they are not interested in the conversation. Whereas during the finals, the interactors are encouraged to engage in the conversation and try to explore different capability of the system. And so here you can see the number of user turns is around 22 like turns, so which is pretty significant. Like if you think about the task-oriented system, they want to finish the conversation as fast as possible, so they tend to have a shorter turns. But here we want to engage the user in the conversation as long as possible. So like we want to have a much longer turn than the task-oriented system. So next, I'm going to talk about our recent work on doing these multi-level rewards for the along socialbot conversations. And so since we have the system and we got lots of conversations, but the conversation is kind of different from the, like, as I said, to the much shorter task-oriented system where it might be only 1 or 2 goals or doing 1 or 2 tasks. So we want to somehow score the conversation with multiple goals and multiple user and system goals. So the goals can emerge as the conversation evolves. Like there will be some content-seeking goals. There can be some content like getting to know each other goals. And so we want to have a score that can be used for like dialog policy learning or system diagnosis. But just having an end of conversation user rating are not enough to doing this, because first the rating is optional, and we cannot get every rating for every conversation we have. And on the other hand, a conversation can have a good and bad segments. So we may do good at the one goal, whereas we do doing very bad at the other goal. But the ultimate conversation rating does not tell you that which part you did good or bad. Therefore, we want to have something that can score unrated conversations. And also, we want to have something that can give us score all these segments of the conversations. And that's what we want to look at, the multi-level rewards. So how do we do that? First, we want to divide the conversation into multiple level segments, where the segments because currently we are doing the socialbot conversation, so they are indexed by the topics. But in general, if you think about maybe a hybrid social and task-oriented system where they can both do tasks and also do the chit-chat, so we can index the conversation, the segments by their goals. And on the other hand, we also have the levels, the idea of levels based on how the topic initiation strategies. So sometimes the conversation can go deeper, so can spawn based on the previous topic. So we may have a deeper level, like deeper conversations. Whereas if the conversation like start totally new topic or new goals, so we want to, so that's kind of top level segments. So then, once we have the segments, we describe 2 models that can give us ratings for the multiple levels, like at the conversation level or at segment level. So I will describe this linear and the bidirectional STM models, which can give us some rating, these automatic scores. And in order to train this model, we identify those factors that are correlated with the user ratings. So we can use those to represent these individual segments as well as the whole conversation. So, so finally, we do some empirical study on both the conversation level user rating prediction as well as some mechanical Turkic evaluation on these estimated second level ratings. So the first step to get these multi-level rewards is to divide the conversation into multiple level segments. So in our system, we use the stack-based topic tracking, which helps us to do that very easily. So in the topic tracking, the system maintains a stack where each entry in the stack is a tuple. It's like the index is topic or the goal, and then we also maintain a memory of post. Like it can be some discussion post, can be some information attributes of the topic. So we call it like agenda. So the stack will be cleared when the user starts a new irrelevant topic or the agent starts an irrelevant topic. But if the new topic is pushed in, so if the agent spawns a topic based on the previous conversation, then we are not going to clear the stack, but instead we are going to push a new topic into the stack. So take the first example in our talk. So the user comes to say, like, the user may have already had some like conversation with the bot, but now user say, let's talk about the book. So the system detects that user initiates a topic that is not relevant to the previous conversation, so it clears the stack. But it decides to back off to a relevant topic because they have nothing to say about the book. So it chooses this Batman versus Superman. And then it retrieves a post about the movie's release year. So it pushes this entry into the stack. So the stack becomes like a single entry stack. And then the conversation can go on, and then at some point the system will retrieve another post about the movie's rating and push that into the top of the stack. And on the at the same time, the system wants to push the conversation forward. So it checks the stack's top and choose the relevant topic, the Henry Cavill. So it starts saying, OK, this is the rating, and then do you want to talk about Cavill? And Henry Cavill, so the stack becomes like something like this. So we have a new topic which is relevant to the previous topic, but there's nothing there right now. As the conversation goes, though, we can have some more posts discussed about this topic. And then, but sometimes the user decides to terminate the current topic, the Henry Cavill topic. So you will pop this entry out, and then checks current top of the stack. Choose a new topic, like Ben Affleck, which is also an actor in the movie. And so then the stack becomes something like this. So therefore, using this stack, we can do two-level segmentation, where the stack actually reflects the life cycle of a topic. So we can divide the conversation into segments about the individual topics. We are specifically looking at two types of segments. One is the sub-dialog, the other is micro-segments. So in the previous example, the whole conversation is about the Batman versus Superman. We actually touched three different relevant topics. So first, we are talking about some attributes about the movie, and then we talk about the actors, two actors, and so the Batman and Superman is kind of always in the stack, so at the bottom of the stack. So we call that the sub-dialog of the conversation. And whereas all these individual topics is always, when they are at the top of the stack, then we are treating as the different segments of the conversation. So we call it a micro segment. So currently the system has no nested sub-dialog because we control the capacity of the stack as a capacity to be 2. So the oldest topic will be removed from the conversation in order to promote a more diverse to cover more diverse of topics rather than refer to a very old topics. Yeah.
So, sorry. So why do you use stack? I mean, you can easily use a tree and then just actually traverse a tree on.
Yeah. So that's the similar idea. Is the tree can be implemented as a stack, right? When you traverse the tree, you're kind of doing.
Right, but I suppose when you pop out, do you just lose that piece of things, or?
Oh no, so that's the last thing. So we actually have a memory of everything we talk about in the system. So the system maintains a long-term memory of all the topics and posts discussed so far. So we are not going to talk about the same topic again and again, or same thing, repeat the same discussions. So once we are able to divide the conversation into these segments, we want to have some scoring functions that can score this, the sub-dialog, macro segments, and the whole conversation. So we propose two scoring. We describe two scoring models. One is the linear scoring model. The other is bidirectional LSTM model. And both models are applied at multiple levels. So we can get both the conversation level rating and also get some the segment level rating. And then at last, I will talk about how we get the features used for both models. So for the linear scoring model, the intuition is pretty simple. So we just treat these segments as some unrated conversations. Because in our data, you can think the conversation can be some single segment conversation, or can be a conversation have multiple segments. So we try to have a linear model to estimate the rating of the conversation. So we have the gamma as the estimate scores of the conversational segments. And then we have the features for conversational segments that are built based on different, that try to characterize the conversation from different aspects. But the thing is, the conversation level features, the segment level features are normalized separately. So we want them to be both central as a zero mean and the univariance. And the UI and the U0 are all the feature weights and bias of the model. So those features, because we only have the ratings for some conversations, so those features are learned from this conversation level rating regression. But if we want to get some segment level ratings, we just reconstruct the features for a segment and apply the same features to the segment and then to give to get a score of the segment. So that's how it works. The other model we try to look at is this bidirectional LST model, where here the intuition is that we try to utilize the sequential nature of the conversation. And so therefore, we can use the recurrent neural network to kind of propagate the context information to individual segments. So here the X are the features for individual segments. And then we can do a linear projection, like transformation to a YI to project them to a lower dimensional embeddings, and then feed into a deep, multi-layer recurrent neural network models. Then we can get kind of a latent segment score at the end, which is just a single unit output. And then in order to get a conversation level score, we just do a pooling function over all these segments, where we look at the max pooling, average pooling, and mean pooling. And then we can kind of get a statistic of all these segment scores. And then we can learn another linear regression to predict conversation level score. So at the training time, we only have supervision signal at the conversation level ratings and try to propagate the supervision signal into the other network parameters. And at test time, we can kind of estimate all the individual segment scores as well as the conversation ratings using this by doing just forward propagation. So now we have the model. So the next thing we want to, to train the model, we need to have some features to represent these segments of the conversation or the conversation. So we are mainly looking at 3 factors that can influence the quality of the conversation. So the first factor we are looking at is the agent factor, where we try to characterize the dialog X of the agent as well as the language use of the agent. The other thing we want that kind of be very important in the conversation is the content factor, because we are doing this content-driven conversation. So we want to characterize the coherence of the content and also how the topic are initiated, and as well as the individual topics mentioned in the conversation. And the most important thing we are looking at is the user factor, because the conversation can interact with the user, and the user provides much more information rather than just the single end of conversation rating. They give you their reactions to the topic, to the content. They kind of propose or reject or accept some topic, or they will request some clarification or help or repeat. And also, they will, in their conversation, in their response, they will show their verbosities are different, their language use are different. And also, in our system, we try to probe the user personality. So we will try to estimate the user use the user personality as to characterize the user factor. So all these features are automatically derived based on the system logs, because the system logs all the system states and the user intent. But we also do some small amount of annotation on the engagement, because that's the pretty vague definition. So to look at the user engagement, we are rather than just ask the Turker to annotate what is engaged or not, we ask the Turker to look at 3 dimensions. One, the first thing is the sentiment towards the content. Like if the user says that's cool, it's they express their opinion about the content. And also we are looking at their interest level in discussing the content. So tell me more. So where they do not express any sentiment, but they want to talk about this. And the last thing is the user sometimes will rather talk about the content, just say the bot, you're funny or you're stupid. So that's the 3rd dimension we are looking at, is their attitude towards the bot or its maker. And finally, we can convert all these dimensions into one single engagement binary indicator by saying if any of these dimensions is positive, then we can treat this turn as an engaged turn. And we do some we did human annotation on 330 unique utterances, and we can see for the inter-annotated agreement is reasonably good. And we train a SVM transport vector machine on individual dimensions, and which get so you can see the sentiment and towards the bot or the content is pretty high. So the interest level is pretty hard to detect, as sometimes the user, it's hard to say whether the user is interested in discuss or not. For example, if the user says, that's sad, that's terrible. So it's kind of harder to know whether the user just is negative sentiment about the content or whether the user actually want to talk about this a little more. And finally, we can convert this, all these labels into one binary predictors, and we can train another classifier for engagement, which get a pretty good accuracy. So once we can get these user engagement labels prediction for each turn, we can kind of characterize, OK, how many turns the user are engaged in the conversation and how many turns the user are not engaged. And therefore, you can kind of divide the conversation into some cost turns and success turns. And so we do some experiments based on the data we collected in the 1 month data collection, which is using a very consistent data system policy. And it gets our 68,000 rated conversations, and the user rating. And you can see the variance of the user rating and duration is very big. But also the topics covered in one conversation is a lot. It's like eight topics in general. And it means the conversation can go very long. And in our experience, we first tried to analyze the factors and try to do some correlation study for all these different user factors, agent factors, like content factors. And then we study how this two scoring model perform on the conversation level rating prediction. And since we don't have the actual segment level scores, we do some mechanical Turk evaluation of the estimated sub-dialog scores. And then finally, we do show some study on the topic initiation policy using the macro segment scores. So for the factor correlation study, so here this figure shows the Pearson correlation between factor and also a feature and the conversation level user rating. You can see the number of turns has a pretty low correlation, but still positive correlation with the user rating. As I said, the conversation can have these good turns and bad turns. You want to, so you don't want. So even if you have a lot of turns, you may just doing all these negotiations. The user keeps rejecting a topic. So that's kind of the cost of the conversation. So therefore, by only looking at the number of turns is not enough. So, but if you look at how the number of user engaged turns, it has much larger positive correlation with the user rating. Also, if you look at the user negative interest in the discussion, so it has a very negative correlation with the user rating. And a lot of these correlations are most highly correlated with the user reactions, like saying the user has a positive opinion about the content, or user accepts some topic, or user has positive interest, or if the user rejects the topic, there is a negative correlation. But also the other, the agent negotiation topic has negative correlation because that's kind of treated as a cost, also as well as the apology. And whereas the agent starts discussing the topic, is kind of the effective terms of the conversation. So it has a positive correlation with the user rating. So now we show that there's this kind of factors all correlated with user rating. We want to see how it works in the conversation level rating prediction. Try to give a rating for those unrated for some unseen conversations. So in this figure, we show the performance of the linear regression model on the validation set. And you can see the number of turns is still the worst. And then the content is much better than number of turns. And the agent is better. And then the best is using the user factors, which achieves 13.1 Spearman correlation. And interesting to look at is even if we merge everything together using all these factors, we did not get a better correlation prediction output. And so that's kind of tell us the user reactions, the user's factors, characterize the conversation pretty enough. And another experiment we did is to try to compare all these different, these two scoring models. We have the linear scoring model and the bidirectional ST models. So their performance is not too much different. And so the linear model is pretty simple, but it's very effective. And one thing to think about is the linear model actually have a more global view of the conversation, whereas the LSTMs, because we are doing the pooling functions, we kind of lose some of the information of individual segments. So therefore, there's some performance drops. And so next thing we are looking at is how good we are doing on these estimated subdialog scores, how it correlates with the user judgment. So we do a mechanical Turk evaluation where we provide the Turker 2 subdialogues from the same conversation and ask the Turker to give an answer on which user is more engaged in the dialogue with the chatbot. And we collect 3 judgments per pair, and we try to compare this linear and the back LSTM model to, on the scoring performance. And we did 2 sets of experiments. One is to control the subdialogues to have similar turns, so that the judges, the human Turker, are not biased to the longer conversation. And so in there, we get 62 pairs with 62 pairs, which excluding all those that cannot tell pairs. And then we can see the agreement with the human majority vote is pretty high, 70%. And also, we did experiments where we do not control the length of the subdialogues, where we have 20 pairs, which is very small study, but we can show the accuracy is pretty high. So because once you have a very different conversation lengths, you kind of can, as we show, the number of turns actually have a positive correlation with the user rating. So you can pretty easily to detect, to understand which one is more engaged. And so the last thing we are looking at is the reward aggregation. So we have, so the conversation have a different topic initiation policy. So for example, the system can accept the user topic, or back off the user topic, or reject the user topic. And also, when the user do not specify topic, the system can either spawn a topic from the previous discussion, or from presupposed, or inherited from an earlier discussion, or spawn from a user utterance, try to find something user mentioned and it can talk about, or just do a random topic proposal based on its prior knowledge. So say if we have like 2 different conversations which kind of have several different segments using different topic initiation policy, and each get different ratings, and in order to compare which policy is better in our system, we can do an aggregation and say, okay, I will look in all the conversations that get using the one random this last policy for the topic initiation. So we can average the rating and get a 3.4 of the score for this policy. And similarly, we can look at the policy for across the conversation and get a 1.4 for the backoff strategy. And therefore, we can average all the scores across conversations and get a rating, get estimate score for individual policy. And here is the result. We can see that the conversation the policy is kind of consistent with our expectation, where if we have some coherent conversation like spawn from the presupposed or inherit from the earlier discussion, then we have the policy kind of get a better user reactions. Whereas like if you reject the user topic or back of the user topic, it will have a lower user satisfaction versus if you accept the user topic. And one thing we're pretty interesting is like if we spawn a topic from the user's utterance, we actually have a very bad performance. And this can be caused by several things. We are looking at the data, and it's actually first, if the user did not specify to change the topic, and we propose to change the topic, sometimes it can be annoying. And specifically, if the system has some language understanding errors, like here in this example, the user say, I watched that movie a long time ago, and the system tried to estimate or to try to detect what topic are available, and treats the a long time ago as a topic, and looking at the back end the content, and to say, okay, I have a lot of things to talk about a long time ago, so I want to switch a topic to that a long time ago. And that's not actually a very good topic to talk about. So it's kind of a bad example for switching the topic using this policy. So finally, I will do the summary. So first, we want to show the Socialbot can be just more than just a chatbot. And we are thinking about the sounding board as a conversational gateway to the web. And we are using this user-centric and content-driven design for the social bot. And second, we propose something to a multi-level reward function to score the long social bot conversations, where we can get a score at both the conversation level and segment level. And we do this correlation analysis for estimating conversation scores so that we can know which factors are correlated with the user ratings. And also we did mechanical Turk evaluation to validate the estimate scores can be used in future study. And as a case study, we do this aggregate macro segment scores to study the dialog policy and to try to diagnose the good policy and the bad policy. And for the future work, we want to use this dialog policy learning using this multi-level reward function, where we can do this more efficient topic and content recommendation and more smooth topic switching. So the good thing about using this multi-level rewards is that we don't have to wait until the last turn to get a reward signal. Instead, we can have a more local reward signal at the earlier stage. And so which is good, which kind of address this reward sparsity issue in many RL work. And also, we want to carry out a deeper conversation about news or event. But it means we need to a much stronger language understanding for both the user utterance as well as the online content. And one thing we are looking at is how can we automatically generate a kind of storyline or agenda of the news to talk about the news, so that we can carry out this kind of discussion, more deeper discussion. And lastly, which is most important, most interesting, is we want to extend our current architecture for hybrid social and task-oriented conversations. So if you think about the future of the conversation system, so you don't want to say like, open this app, and I want to book a restaurant, open that app, I want to talk about like news. So you want to have a more smooth transition between these different tasks or different goals. And we are thinking about this hierarchical structure can be used very well for this hybrid conversation, as well as the multi-level rewards. We can get like a scoring for individual sub-dialogues so that we can learn some dialog policy better using this structure. So lastly, this is our team, and we have 5 PhD students from University of Washington, and Mari is our faculty advisor, and Yej and Noah, who are now in AI2 as well. So they are also give a lot of advices on the team. So that's it. Thank you.